Hey, how you doing today? Mr. H here. Oh dear, look at the top. The Algebra 2 F word has returned. That's right. Factoring is back. Do not turn off the video. Do not walk away. Okay? We're going to get through this together. This semester, this shows up like every unit. I'm not even exaggerating. Well, no, not in the probability unit. But everything else, this is probably going to show up. So we just got to stick our nose to the grindstone and get after it here. So, okay, factoring. Reminders on factoring. Every single time. Every single time. Number one, I left it blank for a reason. Okay. Oh dear, learn how to spell, Hardy. That's why I'm not an English teacher. Anything in common. That's true for coefficients. That's true for variable terms. If there's something in common, we need to get it out of there first. It's going to make our life easier, number one. Number two, sometimes we might need it to do the problem period. So make sure we always check for that first. If there's nothing in common, like there's number two, okay? These are the ones where hopefully, if there's no number in front of the x squared, if the coefficient in front is 1, this is the one where we look to multiply to get the numbers on the end, add to get the numbers in the middle. So, let me get my parentheses in order here. We know they both start with x. And then we start looking for clues. So, first clue. The sign of my multiply number is negative, which means one of these is going to be positive and one of these is going to be negative, because that's the only way we can get a negative product. Our next clue comes from the sign of our middle term. Okay? Our add number is negative, which means the bigger of our two numbers is going to be negative. So, I'm looking for two numbers that multiply to 12. Just for our purposes here, I know we're capable of this in our head, but okay, two numbers that multiply to 12 that are 4 apart. Because remember, if the signs are the same, we're adding. If the signs are different, it's how far apart are they, or we're subtracting. So which pair is 4 apart? These two. And remember from what we just said before, this tells me the sign of the bigger number. And we're set. Okay? So just a couple little things to keep in mind as we're doing this. Okay? Difference of squares. Remember we had that big old long list of squares before? If you still have that from first semester, great. If you don't, I'll try and remember to post the list of squares chart with this lesson. But if I don't, in case I forget, and yes, I know 1 is a perfect square, but typically that doesn't help us much. So I'm going to go ahead and list my perfect squares through 10 here. If we find out later we need more, we can always add. But if I notice, first, that it's only 2 terms, and second, that they're both perfect squares, maybe we even go so far with this as to write what the square root of each one is. Color's helpful, otherwise maybe use a set of parentheses or something. But as you write these, as you see them, as you hear me talk about them, again, we're touching on all your senses to try and help you figure out, okay, how I can get these into my brain. So here's what I always do with difference of squares. What do I square to get my first term? What do I square to get 4? 2. What do I square to get x squared? X. What do I square to get 9? Not negative 9. Don't pay attention to the sign. 3. Okay? And if you notice down at the bottom of this sheet, okay, if you have your factoring help sheet still that we did on colored paper, that's great. You can use that. Otherwise, to help out, we put it right in here. So difference of squares, once you know what your first and second terms are, okay, that's what this A and B is talking about. So in our case, it'll be the 2x and the 3. It's just first plus second, first minus second. So we come back to here. And we go, okay, 2 sets of parentheses. First term plus second term. First term minus second term. And we're done. But you'll always have that flow chart available to you with your note packet. So, not a bad deal. Okay, and then our common factor, which we kind of talked about up here, is our golden rule. And again, it can be a number, it can be a coefficient, it can be a variable, it can be both. So I look at 2 and 10. And what I always want to do with this, when I'm looking for the common factor, I want the biggest number that divides into all of my terms, not just 2 of them, if there's 3 terms, not some, just all of them. And then I also want the smallest exponent. But again, if all terms have a variable. If they don't all have a variable, I can't take a variable out. So like for instance, if you were looking at this problem, I can't take an x out because this 12 doesn't have an x. Okay? So all terms we would have to do here. So I look and I go, okay, what's the biggest number that divides into 2 and 10? 2. Okay? 10 doesn't go into 2. 10 is bigger than 2. Smallest exponent, remember, 2 or 1. So x, if you want to put x to the first, you could. But that's not the only thing I'm going to do here. I'm going to put parentheses. And so then I got to ask myself, okay, how do I get from 2x to 2x squared? Well, I've already got the 2, so I don't have to worry about that part. How do I get from x to the first, x to the second? What do I add to 1 to get to 2? 1. And again, on these exponents, I don't have to put the 1s there, but I can. We assume they're there otherwise. 2 to get to 10, 5. And I already have the x to the first, so I don't need any more x's. I'm done. Okay? So that's kind of a review of what we did before. Okay? That was a first quarter / normally first semester thing. And so again, our flow chart, factor out anything in common. If there's 2 terms, it can be our squares, it can be our cubes. We did our squares up there. Cubes we'll talk about here when we get to them on the back. Lead coefficient here, we're going to add in slide and divide if the lead coefficient is not 1. We'll chat about that more for some of you that are like, weren't here first quarter and you're like, what's this slide and divide thing? It's another tool we got in the toolbox to use when we get to those. And then today, one of the months we're going to start dealing with is when we have 4 terms, factoring by grouping. Okay, finding the greatest common factor. So speaking of that, we're going to head to the back here. Now, we're going to be doing some flipping back and forth. Actually, I'm going to cheat. I haven't gone away. I'm just grabbing a secondary packet here because I would like to have, holy moly, I didn't know we'd done this much already. There we go. I just wanted an extra packet sheet so we can kind of reference these forms as we go. Maybe I'll just write them on a sticky note. That's a good idea. So I look at this first one and I go, okay. So I'm looking at my chart. I'm flipping back and forth. And it looks like I see x to the third. So I'm like, I wonder if this is a sum of cubes because it says plus. So if we're doing cubes, I'm going to make a cubes list up here. Again, I'm going to try and remember. Somebody might have to remind me here about getting a cubes list up. So let's see, 1 cubed we don't care about really. So 2 cubed, 3 cubed, 4 cubed, 5 cubed, 6 cubed. Are we going to go bigger than that? I don't think we are. So I'm just going to do that for my cubes here. So 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed is 216. And we're going to treat this just like we did the difference of squares in the front. In other words, what do I cube to get each of these? So I cube x to get x cubed. I cube 3 to get 27. And then I'm going to follow the form. So I'm going to put the form on a sticky note here, because that way it's going to move around with us. So when I'm doing a sum of cubes, and this is the same one that you've got on your flow chart, just on the other side of this paper. So maybe, I might even suggest to some of you, if you have like a piece of paper or a note card or something, maybe putting some of these forms on there so you've got it handy and convenient right away. I might do that too for the next lesson we get here. So I'm going to look at this and I'm going to go, okay, so what's this say? It says first plus second, because that's my A, that's my B. So first plus second, okay. Then square my first term, minus, follow all the signs that they have here that won't do you wrong. AB means multiply these together. 3 times x is 3x. And then plus my last term squared. 3 squared is 9. Cool thing with sum and difference of cubes, there's nothing else to think about. You plug the numbers into the form, you're done. And that's it. Okay? I'm not purposefully skipping it. I'm going to skip over 2 for a minute, so I'm not forgetting it. Let's say it that way. I'm going to go to 3 because I want to get on a roll with these for a second. Same thing. I see a cube. Okay? So again, what do I cube to get 27? 3, and x to get x cubed. I cube 1 to get 1. Ignore the sign. The sign's only going to come into play when we're doing the form, which is slightly different when there's a minus in the middle. Okay, if it's a difference of cubes, we're going to do a minus b, sign change, a squared plus ab plus b squared. So notice the plus and the minus, those first two swapped, is all that's really going on. Other than that, we're going to follow it along. So first minus second, whatever symbol we see in the original problem. Now, we're going to square the first term. We're squaring the 3 and the x. Okay, don't forget to do both. Plus, multiply these together. 3x times 1 is 3x. Plus b squared, plus 1 squared. Boom. Okay. So just keep the form handy. No big deal. Now, I wanted to throw a twist in here just because, and this is going to happen. I'm guaranteeing it's going to happen on some of the summatives that we do. You're going to look at this and go, wait a minute, Hardy. I'm looking at my flow chart over here. I don't see anything to the fourth here. What's the deal? What's going on? Here's what I want you to do on this. We're going to treat this like it's 25x squared minus 36. You're like, but that's not squared, it's to the fourth. But it's still an even exponent, and even exponents are all going to work the same way. So let's do this like it was 25x squared. So if we did that, we'd say, okay, what do I square to get 25? 5. Ooh, now think here. What do I square to get x to the fourth? X times x is x squared, because 1 plus 1 is 2. What number plus itself is 4? 2 plus 2 is 4. So my first term, instead of just being 5x, it'd be 5x squared. What do we square to get 36? 6. I still say it's worth the extra time to write those things out so we don't mess things up. Because now I do my difference of squares, which is first term plus second term, first term minus second term. And maybe, just maybe what I would do within my notes right now, I would kind of hang on for a second. I'd flip back to that first page and make myself a note. Difference of squares, I'd put like x squared x to the fourth, just to remind me, ooh, if something's to the fourth, I just treat it as though it was squared. I'm just going to have squareds in there instead of something that's just x. Just something to consider. One's done. Whoops, that one's done. Now we get our newbie. 4 terms. 4 terms here says we're going to factor by grouping. Group the first 2 terms and the last 2 terms. All right. Colors are helpful here. Group the first 2. Group the last 2. Okay, parentheses everywhere. Then the next part says factor out the greatest common factor of each. Okay, here's what that means. We're going to forget the second part, the red part here, in my case, exists. That's out of here for now. If that was your problem and we were factoring it, what would you do? Well, we'd look to see if they have anything in common. So I'm looking, I'm like, well, numerically, no. Ooh, x's though. Smallest exponent. take out an x squared and factor what's left. Okay, I have x squared. I need x to the third. How far away from 2 is 3? 1, or x. You want to put x to the first, you could. What about to get from here to here? Well, I see there's a -2, so I know I need that. But I already have x squared. I don't need any more x's here. So that first set of parentheses that I created is factored. Okay? Once I do that, I switch gears, and I do the same thing to my red set of parentheses, my red quantity. Does anything divide into 5 and 10? Yes, 5 does. Okay, so what do we got? Well, I've already got the 5. I need the x, or the x to the first. 5 times what gets me -10? -2. What should happen, if I've done this right, is that the 2 sets of parentheses I have left over once I take out my greatest common factor should be identical. If they're not, something went wrong somewhere. Either didn't take out a large enough value, or I forgot to take out a value, or I messed up a sign or something. So keep digging. It's like a puzzle. It'll work. You just got to keep rearranging it until you get there. So is that how I leave my answer? No, there's one piece left. Now, to write my answer is going to be my greatest common factors together in one set of parentheses. So I put those together. And then my common set of parentheses or quantity will get put together as well. And I'm done. Okay? So it's really just doing the factoring part here and then just putting it back together at the end. Let's play with another one of these. So we look at number 5. We go, okay, 4 terms. Already says when there's 4 terms, well, the flow chart says, pair them up. Cover the other one up. What do they have in common? Anything dividing into 2 and 3? Besides 1. I know somebody out there said 1. Nope. So what do we do? What about the variable part? X squared. Okay, so what's that leave me? Well, I see the 2. I have 2 x's. I need 3. I need 1 more. Again, if you want to put the first on there, you can. Then over here I see I need a 3, but I already have 2 x's, x squared, so I don't need any more. So now I know I've got a little hint on what the next one should look like. I know when I get to the end, I should see 2x plus 3 in the parentheses. So let's see how this goes. So I look at the next one, and I go, 2 and 3, yeah, nothing really in common. Well, wait, they don't have a variable either. Hardy, they don't have anything in common. Kind of. Like, what do you mean? I've always got to take something out. So if I don't see anything numerically or with a variable, I can take out a 1. But in this case, since these are both negative, I'm going to take out a -1. Okay? So if all else fails, take out something, you take out a 1. And so you're like, okay, so -1 times what gets me to -2? 2. And I need the x, because -1 times 2x would be -2x. -1 times what gets me to -3? +3, because negative times positive is negative. Look at that. Okay, they're the same. And so like what I did on the last one, take the pieces, my greatest common factors, put them together, put my common set of parentheses together. Now, we've done a solid job here. There's one detail left. You're like, seriously, dude? Yeah. Be sure to check remaining terms for further factoring. Uh-oh. This will be the one we're looking at. Now what is, x squared of what? Oh, perfect square and perfect square. So I got one more piece I got to do. This is a difference of squares. Now, will this happen often? No. But does it? Well, we just saw it does. So difference of squares, flip back over to the front if you need. First plus second, first minus second, and then this one doesn't change at all. So whichever part, if you're factoring and there's a squared part left, you've got to check and see if it factors or not. And it's not going to every time, but it will sometimes. Yep. That's why we call it the Algebra 2 F word. It can be frustrating. Okay. Can be fun sometimes. I know I'm kind of sick that way, but it can. Now we're just going to kind of go into a hodgepodge here with some of these last ones, just to make sure that we're in good shape. If you're at this point feeling like you're in good shape on these and you want to go start trying the practice, you fast forward me, turn me off, mute me, whatever. But okay, number 6. Let's see. Now, you see the cube, you're like, difference of cube. No, it's 3 terms. Remember, the number 1 rule every time, is there anything in common? So I look through. Ooh, Hardy, they all have x's, okay? Smallest one is just x. No number they have in common. So x is all I get to take out here, x to the first, if you want to look at it that way. How do I get from 1 to 3? I need 2 more. Because again, exponent rules, we add. How do I get from here to here? Well, I need the 3. And I have 1x and I need 2. I need 1 more. And then here I see I need the -10. And I already have the 1x. Now, there may be an occasional time or two where this would be all I need to do. But whenever I see x squared, I'm always thinking I'm probably going to be able to factor more. So this looks like a diamond. So this is multiply, this is add. Let's see if we can do anything to this. Probably can. So x and x. All right, first clue. Multiplying to a negative. One of each sign. If it's positive, they're either both positive or both negative. Bigger number is going to be positive. So 10 can be 1 and 10. It can be 2 and 5. Which pair's 3 apart? This pair. Bigger number is positive. 5 and 2. Bam. You will get this slick after you start doing them for a while if you don't quit. I mean, we've talked about that before in the motivation and different things that we do. If you don't quit, if you keep going, you tend to get better at things. It happens. Okay. 17. Holy macaroni. Okay. X to the 4th. Remember what we deal with here. It's like 16x squared minus 625. You're like, okay, that's still kind of big, Hardy. Well, let's see. 4 squared is 16. What do I square to get x to the 4th again? X squared, because 2 plus 2 is 4. Now, 625, if you don't know that that's a perfect square, I kind of understand that. I don't blame you. So let's see. Let's check. Square root of 625 is 25. Okay. 25. And now we know the drill. It's just like when we were up in number 2. Actually, I'm going to do it this way. First plus second. First minus second. Now, before you circle it, because we've done a good job here. We've done a good job. But do either of those factor further? Now, some of you are going to look at this and go, yeah, look at, they're 4 and 25. Those are perfect squares. They both factor. Wait. There's a difference of squares. Okay, we're going to make one more note over here. There is no such thing as a sum of squares. No such thing. So what does that mean to us? That means this part is done. Sometime if you're curious and want to know why there's no such thing as a sum of squares, I can prove that out for you, but I don't think all of you want to sit and watch that right now. But if you want me to, let me know. I'll make you a video. I'll shoot it your way. Here, though, difference of squares, I can do because of that minus there. So here, I'm just going to do first plus second, first minus second. We're good. Okay. All right. I want to do one more here. We're going to do number 8, and then I just want to talk a little bit about the worksheet and what we're going to look at that, and I'm going to let you go on the last 2 here because I've already held you for quite a while here, and I appreciate your patience and your willingness to stick through it with me here. Okay, number 8. Anything in common? Because that's always the first question. 7. Okay. We got a 7. What about variables? we have an x, or an x to the first. Okay, so we get 7x out of there. Now it's just piece by piece. I already got the 7. Don't have to do anything with the number. I got x to the first here. I need x to the third. X squared. 700 divided by 7 is 100. And I've already got my x to the first, so no more x's. Am I done? You know the answer, don't you? Yeah. I'm not done. Difference of squares, that's a perfect square. I square x to get x squared. I square 10 to get 100. So, don't lose my 7x that's already there. Difference of squares. First plus second, first minus second. And we're set. Okay? So there's a lot of stuff in play here, and that's why we practice this a bit more, and it keeps coming back to give us those opportunities. This is a building block. Okay? This is one of those things that you can't really make it through algebra without having a little bit of a grip on. And that's why we give you the flow chart and let you kind of work through some of these things. So my suggestion on the practice that's after it is, do the evens, okay? Do the evens. This is a two-sided worksheet. Do the evens. If you're going good and you check your answers, if you have the packet, you have the answers. If you don't have the packet, the answers are in one of the PDFs that are online in the stream, okay, in the classwork stream. If you're doing good after the evens, good, you're done. If you need a little more practice, try the other ones. Shoot me emails if you're having trouble with this. We can walk through some of this in different places, but do the practice. Because if you don't do the practice and you go to do the online stuff with the quizzes and the delta math, oh, buddy, that's not going to turn out well. So keep me in the loop, keep trying, and trust me, that F word will turn from frustrating into, well, fun's probably a little over-exaggerated, but it'll make it a lot better, okay? Have a good one. We'll see you next time.